have the document, we'll make sure that you get it. But I'm going to share my screen and begin. If something's not clear, please stop me. I can try to translate into Lithuanian, but my Lithuanian is very kitchen. It's a kitchen-oriented language. Okay, so the first thing that I want to encourage the students, and I don't know who everybody is. We don't have time for introductions. If you have zero experience with structures, don't worry too much. This is a problem, not just at your university, it's a problem in most universities. My university is one of the few that has a serious structural program for the architecture student and a fairly serious architecture program for the engineering student. It's very rare. So if you are nervous, don't be nervous. This is supposed to be fun. Just learn what you can. It occurred to me last night that some of you may not even understand the basic definitions of what we are doing today. So I will just start with the basic definitions for 1 minute. If you take a pencil in your hand and hold it at the tip, so especially if you are new to structures, and you take a pencil and you hold it like this pencil is stable. It's okay in three-dimensional space. But if you push on it this way, what you feel is a turning force. You feel a turning effect in your fingertips. And we call that a moment, M-O-M-E-N-T in English. And I think it's moment, but I'm not sure. That term is very important, and even something like that is confusing. I remember hearing this term for the first time when I was a student, and I didn't understand it. I understood what a force was, but I didn't understand what this spinning or turning effect is. So please take a pencil and then notice that the turning force is reduced if you move your finger closer and closer, and now there is no turning force. So the turning force, the turning effect or the moment depends on two things: the magnitude, how large the force is, and how far that force is from the point being investigated. If this was a column in a building and we were gripping it like this, we would say this is pinned, P-I-N-N-E-D, and I don't know how to say that, pinned. So, and what that means is that it cannot translate. It cannot go left or in and out of the page or up and down. It is not moving or translating, but it can, the element can still rotate. So what we will do in this workshop is draw the diagram that captures this bending. And it's as simple as what I just said. The bending is at a specific point in the structure, and the bending will change depending on the loading configuration. And that will be called a bending moment diagram. And we will only look at 2 dimensions in this workshop, which is very traditional for structural engineers, to look at a 2-dimensional surface. And that will be either counterclockwise or clockwise. The whole point of this exercise is to give you a geometric understanding of this, because many people in this room know exactly how to do this algebraically, but I'm almost sure that nobody knows how to do this the way I will present it to you today. One more definition, a bay. We will look at a bay, B-A-Y. And a bay is like a portal, port, Französischkeit, or a doorway, like a door. So I have a picture of a portal or a bay, one bay. So typically just two columns, one beam, and we call that one bay. And that whole system is called a frame. Ramas, that's a frame. Okay, I think that's all the definitions we really need. So now the first question is this. If the architect or the designer decides to make the column shaped like a letter V, where it's narrower at the bottom and wider at the top, just from an artistic design idea, what does that mean in terms of performance? The question is, if I am a structural engineer and my architect wants me to have a narrowing column, then it doesn't make sense for me to say that the bottom is not pinned. It makes sense for me to say that the bottom is pinned. And I'm going to take my pencil and just show you this. I'm going to grab the tip of the pencil and just say, this is the narrowest part of my column. Yes, I can try to fix this and have this to be a fixed connection, like a diving board, like Mueller-Breslau. But it doesn't make sense if this is getting narrower and narrower. I can try, but it just doesn't make sense. So I show a picture of a table lead, stalo koya, and that leg is a good physical example. Everybody in the room knows roughly what this is like. The thing that students don't know is that the opposite is also true. So if you have a column that's wide at the base and narrow at the top, what does that mean? So that's this picture here. Now, students and architects, I think, have trouble understanding this. If it's wide at the base, and I mean from an artistic point of view, and narrow at the top, it really does not matter how stiff the beam is. This connection is essentially like the pencil point. Yes, there's a little bit of moment transferred to, and what that means for the people in the room who don't know structures is, yes, there is a little bit of bending up here, but it's not efficient, it's not effective. So it doesn't make sense to have narrow columns at the top and a very stiff beam. All you're doing is vertically supporting the beam, which is a fine design, but it's not a frame. That is not a frame. A frame means that this is carrying bending, that joint actually transfers bending from the column to the beam. That is the definition of a frame. Otherwise, it's simply two columns and one beam. And there's nothing wrong with that, but it is not a frame. So now you may say, okay, Edmond, what are we talking about in real life? You're showing me a pencil, you're showing me a table. Well, in real life, if this is steel, pliamos, we could focus to a point and make that connection clear to the viewer, to the client, to the people walking by your structure, that the people looking at this structure may say, I wonder if they took Edmondus's workshop. That looks like a pinned base. And that is what I want you to say. I was talking before the seminar. My goal as an educator is to have rational architecture come back instead of irrational architecture. Now, in concrete, the same thing happens, but we don't see it very obviously. So we have reinforcing bars that often crisscross. They form an X. but the viewer walking by does not see it. Only you know that if it's concrete and if the designer took my workshop, that is a pinned base. There are many examples of this in real life. My favorite is Robert Maillard, M-A-I-L-L-A-R-T. He was a Schweitzerist, a Swiss, brilliant engineer, and he detailed such that even he would put cork, soft material on the sides to really have a large rotation of the column. Okay, so now this is the structure that we're going to look at in this workshop for 2 days. It is pinned at the bottom, and in my university and many other universities, we use a triangle to represent this connection. You could also use 2 arrows. You could just use a vertical arrow and a horizontal arrow, but the triangle means that it is pinned. The frame has a width, W, and a height, H. And there is load on the frame, but the load is only on the beam. It is not on the columns, only on the beam. And here is something else that I must define. This is the material. The E is the material, and the I is the moment of inertia. What that means is, what does it look like in cross section? Skerspjūvis. What does that look like? And the E is the material. Is it steel? Is it concrete? Or is it wood? So what I'd like you to do right now, this is your first assignment, and I won't grade this, so don't be nervous. Take a piece of paper, and this is the kind of paper that we use. I bought this in Yatava, actually, for €2, I think. So with the little langale, the little grid. So so everybody in the room now, don't turn the page if you have my handout, because I have the answer on the next page. Everybody draw the bending moment diagram. If you are a first year Fuxas, you don't know how to do this, that's okay. But the senior people, draw the bending moment diagram right now. Nupieškite man diagramą dabar. Without any numbers, no numbers, just draw it right now and see what you get. It does not matter if you draw the moment on the tension side or the compression side. In Europe, we typically draw the bending moment on the tension side. So that would be under the beam. So go ahead and do that right now. If there's anybody who's really, really nervous, you could shoot me a chat and I will try to address your nervousness. Just put it in the chat. I think I can see it. Jeigu kažkas tikrai nerimauja, tik atsiųskit man žinutę, palaikysiu jums rankytę. Okay, so let's see. Drum roll. All right. So hopefully you got to picture something like this. Something like this. That the bending is greatest in the middle of the beam. The bending reduces, but it is not zero at the corner, at the column. And because there is no wind or earthquake, there's no sideways load. We have a straight line on the columns. Okay, if you did not get this, how about a quick show of hands? Just show your hand. How many people got it? Just raise your hand. Oh, okay, Vivek, yeah, okay, David, gerai, we give you PhD, David. Okay, very nice. Okay, and nobody else got it, I think. Yedra, did you get it? No, okay, that's all right. Okay. Okay, so, gerai parodykit, puiku, labai gerai, sveikinu. Okay, okay. So now, how did I get that? Well, I will explain how I got that on Thursday, but the key that is today, antradienis, is this horizontal thrust, horizontal thrust. Now, ladies and gentlemen, what I mean is this, and let me stop my share for a second. My students like this image, and you will like this image too. This is the giraffe on ice. Girafa on lado chojito. The giraffe is standing on the ice and the legs want to open up. There is no sideways load. The giraffe has load going down. And always, always, there is horizontal thrust. We call that thrust. You could just say horizontal force. If that doesn't make sense to you, just remember the giraffe on ice. You will remember that for the rest of your life, I guarantee. Okay. And giraffe is a very nice differential word. Okay. So what is the giraffe on ice force? The sideways one. The vertical one is easy. Half of the load goes to one column, half of the load goes to the other column. No problem. But what is the giraffe on ice? I won't tell you the trick today, but I will tell you the trick on Thursday. So now, before we get to the trick, what does all of this mean in terms of architecture? So here are some sketches of structurally rational columns that I am discussing, where it is narrower at the bottom. And architects and engineers, bridge designers, everybody who took my course, including Corbusier here on the left, and Pierluigi Nervi, they all took my workshop and they all understand that if it is narrow at the bottom, that this is a very interesting design idea. It does not make sense to try to make the bottom of the structure fixed if it is a V-shaped column. Okay, so now the next definition is not really statics, it's a definition. What is that moment? What is that moment? And that moment is simply this, one more time. How far am I from the point? The moment is the magnitude of this force times this distance. But I admit that that sounds like algebra, and I promised you that you will learn to do this without algebra. So I will give you some secrets right now. Okay, so if I know the thrust, the giraffe on ice, if I know that, then at the top of the column, the magnitude of the moment is that force times h. The horizontal thrust times the height of the frame h. But I must know what that thrust is. And now we begin our secrets. So I will teach you briefly the modern Mueller-Breslau method. Now, Mueller-Breslau was a very interesting gentleman, and he was a fantastic teacher, 19th century. So, the middle of the 19th century. He did not solely invent this idea, but it became a political battle. As academics like to do, we like to argue about everything. So he won the battle and his name was associated with the method. But what I did in my own research is I reinvented this method. So I'm calling it the modern Mueller-Breslau method, because I don't want to call it the Saliklis method. That would be too much ego. So I'm calling it the modern Mueller-Breslau method. And I will explain this right now. And you have to learn a little bit of the modern Mueller-Breslau method for your homework. So the modern Mueller-Breslau method is this. It's an energy expression that I can find the moment multiplied by the rotation plus all of the forces that are on the structure multiplied by their movement. And this movement is what I'm calling loft. And I'll explain all of this very, very clearly, hopefully. So the modern Mueller-Breslau method is this, that I move theta, this angle, the angle that the column makes, and I swing it. And all I do is say moment times theta plus this force, which is the giraffe on ice, times this distance, which I'm saying is lateral loft, is equal to 0. Now, let me explain the word lateral. Lateral means sideways. So I know sometimes non-native speakers have a difficult difficulty with the word lateral. Lateral means sideways. And loft is a very common word. How much does it move? Okay, so let me stop this share and let's open up GeoGebra. So hopefully you have GeoGebra on your computer. GeoGebra is a very interesting program in that it is for children. So I will open up GeoGebra right now. And there are many versions of GeoGebra. Let me share my screen. But I like number 5, classic number 5. So let me explain why how to use this program. And you could use this for homework, or you could sketch this, or you could do it in Grasshopper or something else. But yeah, geogebra.org. So if you have not downloaded it, please download Classic 5 Panktas. Okay, so this is a children's program that teaches geometry and algebra. And that's why it's called GeoGebra, geometry and algebra. It's very easy to use. The only thing that I would like you to remember is that if you put down points, they must start with a capital letter. So let's put in A in the input bar down here in the bottom. I'll change my, you could change the font size to be larger so everybody sees this. Okay, so in the input bar, type A equals parentheses, and let's just say 0, 0. This is Cartesian coordinates. A equals 0, 0. Let me stop share for a second. I'm hoping that people are doing this in GeoGebra. If you're not, you could just do this on a piece of paper. That's fine. But I think this is easy enough that you could do this in GeoGebra. And don't be nervous. It's for children. So it's way easier than Grasshopper. So okay, so A is 0, 0. Now the nice thing is in GeoGebra, it's easy to put the slider in. So the slider is up here on the top. All of these buttons have other menus under them. You could see so
Edmond,
many
you are not
things.
sharing right now.
Oh, sorry. Yep. Okay, so all of these buttons have sub menus, as most computer software today has. many items. But I want this one. It's the second to the last, prieš paskutinis, and it's slider, this one. And let's put a slider in somewhere. It doesn't matter. Just drop it down on this canvas, and we can call it height or aukštumas. You could do it lietuviškai. And the minimum doesn't matter. Maximum doesn't matter. It does not matter. All of it is fine. Anything that you want. And now we have the height being a slider. Okay. So now I want point B to be point A plus the height in the Y direction. I will repeat that. I want point B to be the height A plus the height. So here I type it in. B in the input bar equals A, which now it's blue. You see how it's blue? That means that GeoGebra knows what letter A is, but B is gray. It does not know what B is. So now I'm saying B is A plus nothing in the X and height or aukštumas in the Y. And you could zoom out with your mouse. Oh, stop. There's an animation. And there it is. There's B. Obviously, move the mouse, grab the mouse so that you can move point B. So now point B, and if you did, I'll repeat that if you didn't do it. So I will delete this. I will do it one more time. B is equal A plus left parenthesis 0, 0. Oops. Let me delete that again. B is A plus 0 height. Okay. And now I have B being a parametric. It's a parametrinis modelis, but very simple for children. Okay, now I need another slider. So put this slider in here, and let's call it width or plot or plotumas, I guess. One doesn't matter. Width doesn't matter what the width is. And now C, point C is B plus width 0. This is animating, sorry. So let me repeat that if you did not get that one. I will delete point C. So notice what I'm doing. The algebra window has algebra. The graphics window has the geometry. And the input window on the bottom is how I input commands. So I will delete this by just touching it and repeating one more time. C is B plus width, comma, 0. Okay. And now it's dynamic, looks good. And finally, D could be A plus the width, or C minus the height. It doesn't matter. So let's call it D is A plus width, and no, there it is. Okay, so hopefully you have 4 points. I can repeat that if somebody's confused. Let's draw the frame. It's under the third button here. These are all lines. So you could see line, segment, vector, polyline. I want segment. It's a brūkšnis, just a little piece of a line with 2 end points, segment. Okay, so it's the third button here, 1, 2, 3, and then you drop down segment. And very intuitive, just touch, touch, and touch. Okay.
I don't know if everyone managed that, but
let me try again.
Yeah, maybe you can go back all the steps one by
Yeah,
one?
we can go back all the steps. Okay,
Yeah.
very good. Good question. Okay, so all the steps. So, yeah, thank you for the question. So I'm going to start all over again. I'm gonna delete
In my
this.
case, when I was creating the B point,
Yes.
it was creating slider instead of the
Okay,
B point.
okay. Okay, so let's start all over again. So A is 0, 0.
I have a
Okay.
question. Or can
Yep.
we just put the point on the drawing, on the paper? It is also the way, yes?
You can, yes. Yeah, you'd get the excellent question. So notice what I'm doing now. You could just take this and drop it anywhere.
Yes,
But
and
the
you are not
problem-
sharing again.
Oh, pardon me?
You're
Yeah,
not
sorry.
sharing it.
Yeah, this is very difficult. Okay, so yes, the answer is yes, you can do that. You could take a point and just simply drop it down like this. But here's the problem. This point is not controlled. It's anything at all, right? So there's no control over that point. But the first point, we can certainly drop that down here. That's easy, and that's fine. But the second point, if I put this up here, the problem is that, well, you could do that. It's just not super parametric. So I would prefer you to not do that, but you could do that.
Okay,
But-
let's do your way.
Yeah. So now let me show you how I would like you to do it.
Okay, Puiko.
A in the input bar equals parenthesis 0, 0. Okay. And then here, now I'm going to put a slider in, and I'm going to call it height. And the numbers don't matter. You could change the numbers to anything you want. And now I have lots of control because all of my points will be linked to point A. So now I can say, now this is where Andres made a mistake, I think. You have to go back to the input bar here and make sure the cursor is blinking and say B is A, and now it's blue, plus 0 and the height.
And what does it mean 16.9, for example, in your case? It's not a coordinate.
It is the coordinate. So now for here, it's 27. Let's say this is 10 meters, okay? 10 meters like this.
Yes, but we see that the coordinate of this point is 40, 45, or doesn't it mean anything? X and Y, should we look at these axes or no?
Yes. Hang on. So.
Now I see.
You see it. It's,
yeah.
Do you see now that it's actually the X is 0? You could see it here on the algebra window.
Okay.
And the height is linked to my slider.
And when you are creating the other point and the other coordinates, is it important to put spaces between the symbols? Because I know
the spaces don't matter at all.
Okay.
So let's try point C now. Let's go back to the input bar. C is B plus, oh, I don't have the width, sorry. Let's go back. So let me put in another slider. So go back to the slider over here, and let's call it width, or how wide is your frame. Okay, and now I could drop down the D so you could see it.
So
and
actually,
now, yes?
Actually, we are creating the regulating device of width and height in the screen.
Yes.
Okay, I got it.
Yes.
But
Yes,
just
absolutely.
now.
Yes, you're making a parametric model. Yes, so now you could have any size frame to study. Yes. Okay, so now C, go back to input, is equal to B plus width 0, because I'm only adding the horizontal component. And now you could see that C is linked to B parametrically, and B and C are now linked to A parametrically. And that's very different than what, I think that was your gift, but I forgot who that was. That's very different than just dropping
Yes,
a point
I
down.
understood the idea of creating those in Lithuania. They sound very funny, slunkiuostes. It's the first time I hear this word in Lithuanian. But the program,
Which word?
sliders in
Sliders.
Lithuania.
Yeah, how do you say it in lietuviškai?
Slunkiuostė. Bet aš tik šiandien tą
Slunkiuostė,
žodį
wow.
sužinojau.
Wow, man irgi gražus
Slunkiuostė.
žodis. Slunkiuostė. Aš tik parašysiu. Slunkiuostė, I love it. That's better than sliders.
Taip, lietuvių kalba yra nuostabi ir lietuvių kalbos komisija ir ten ta visa institucija yra
I love
nuostabi.
it. Okay, we'll call it slunkiuostė vertically and slunkiuostė horizontally. Very nice, very nice. Okay, now the fourth point, you see obviously that we have two choices. We could have it based on A or we could have it based on C. It does not matter. So the last point is D is equal to A plus width 0. Okay, very good. And now we are good, I hope. Okay. Everybody okay now? Okay, very good.
In progress.
Okay, so now, go ahead. Okay, so now let's draw the frame, the ramas. So it's take this third button here, this third button. And remember, there's many, many choices here. Under each of these windows, there's many, many options. So we're going to do this one. Then it will be segment. And I'm just simply using my mouse to connect the dots. And now I could slunk, and I have a parametric model that is easy to control. Okay, lots of learning just happened. Okay, now I will make your heads explode, especially the professors in the room. I will show you how I did this picture here. So this picture, notice that the giraffe on ice is following a circular path.
Edmond, sorry, we are still seeing GeoGebra screen.
Yep. I just realized that. Notice now that the giraffe on ice is following a circular path. Ratas. It went up as I moved this stick. Now, how did I do that? Okay, so now I show you how I did that. So let's go back to GeoGebra. And I would like you to draw a circle, rata, that is centered on B. Kurio centras yra taškas B. So the circle is over here, but there's a few choices, so be careful. Pamažu. Go to this button, the sixth button, 1, 2, 3, 4, 5, 6. And don't do this one because that's an arbitrary circle. I will show you. Don't do this one because it's arbitrary how big the circle is. Go to this one, circle with center and radius. Centras ir atstumas, I guess. So touch B, and now it's asking what is the radius? And the radius is height. The radius is height. I will repeat this for you if you are lost, okay? So what did I just do now? Now I created a circle that is centered on B. So I will delete this and do it one more time. Circle, not center through point, but center and radius. Touch point B. And now GeoGebra is asking, what is the radius? Radius. And it's height. Okay. Boom. Did everybody get that? If somebody didn't get it, shout it out. Otherwise, if you're drawing this on a piece of paper, just draw the circle. That's fine. Okay. Now we can do what Jurgita was suggesting. We could take the point, go to the point icon, just this point, and drop the point somewhere on the circle. It snaps to the circle automatically. Hit escape, and then you'll see that this point is snapped to the circle. And I will draw a segment. So take a segment icon here, the third button, segment, little line, not a long line, and draw a segment like this. So now what we have is this situation. And this is the modern Mueller-Breslau method. So let me delete everything and I'll show you one more time if you are lost. And I'll try to say it differently too. I'll say it in both languages. Okay, so we want a circle centered on B. Circle, not this one, but this one. Touch B, and the radius is height. Now take a point, go to the point icon, and drop the point on the circle. Not here, but here. And now you see it is stuck. It is, you see the priktibes creatorato. And now draw a segment. Okay. Does anybody need help on that? We okay? Okay. Okay, so now what we want to do is do something like this. I'll show you. Let's go back to our handout. So the modern Mueller-Breslau method means that moment times angle is equal to this force times the loft, not the height, but the loft. This is why it's different. So I give an example here. I give an example, and we're really going slow, but that's okay. If let's suppose the force, let's just do this algebraically, and I'll show you what I mean here. The moment at the top of the column must be, by algebra, the horizontal thrust times the height. The moment must also be, by Mueller-Breslau, the giraffe on ice times this distance divided by theta. Okay, so let's pretend that the giraffe is 100. So write down, giraffe is 100. So now we know that this is the giraffe force. You don't know this force yet. Ladies and gentlemen, you do not know this force yet. Let's pretend it's 100. The moment should be 690 because that is because that should be the giraffe times the height. So let's write this down. Moment algebra is giraffe times height. And you could use a star. Jūs galit žvaigždę naudoti čia dėl multiplication, padauginimo, or you could just use a space.
I think we need to go back to GeoGebra again.
Yeah, sorry. Thank you. Boy, this is very... I do this for a living, you know. Čia mano profesija, aš vis tiek nežinau ką. Okay, sorry. All right, so let me delete this here one more time. Okay, go to input and say giraffe equals 100. This is the force that I'm not telling you how to find this today. We will find this on Thursday. So the giraffe is 100. Now, type that. So I repeat one more time. Everybody, type this in the input. Giraffe equals 100. Now, the moment by algebra is giraffe times height. And you could resize this screen here, 690, that makes sense, right? So if I change my height, my moment changes. Vėl noriu pakartoti, jūs nežinot, kas tas girafos apkrova yra. Aš jums tik duodu. I am just giving you this force of the giraffe. That is algebra though, and I promised you that I would teach you to do this without algebra. So now I will teach you how to do this without algebra. What I need is this horizontal distance. Let me stop my share and go back to the screen. This is very important. And if you had physics, everybody in the room had physics, at least in high school, gymnasium used to do physics. The work of a force is only effective when the distance is in the same direction as the force. I'll say this lietuviškai. Tas darbo jėga tik tai galioja, jeigu mes padauginam tą atstumą, kuris atitinka mūsų apkrovą. Tai tas atstumas turi būti horizontalinis. Tas atstumas turi būti horizontalinis, ne vertikalinis. The vertical movement is inconsequential. It does not matter. All I must have is this horizontal movement. Now, there's many ways of getting the horizontal movement. If you're drawing this on a book, you could just count the squares. It's very easy. Just count the squares. In GeoGebra, there's many ways of doing this. I will show you two ways. I will show you two ways of doing this in GeoGebra, and there's probably more. Okay, the first way, which I think is very easy to see, is I will draw a vertical line through the bottom of the column.
We need a screen share again.
Yep. I will draw a vertical line through the bottom of the column, and then I will draw a vertical line through A, even though I already have a vertical line, but I will show you how to draw these vertical lines. Very easy in GeoGebra. So it's the fourth button, 1, 2, 3, 4. Parallel line, or perpendicular, it doesn't matter. Parallel. So if you're confused, you hold your mouse and it tells you select the point and the parallel line. Jeigu jūs nežinot ką daryt, palaikykit pelytę ir ji pasakys jums, ko ji ieško. Select point and parallel line. So the point is F, and the parallel line would be my y-axis, for instance. Let me repeat. Parallel line. Select the point and select the vertical axis. Or I could select the column, it doesn't matter, the point, and I could select this column, it's still vertical. Or I could go perpendicular, and I could select the beam and the column first, it doesn't matter. So lots of different ways of doing this. Parallel line, point, vertical axis, okay? And now, parallel line, point, and now I have two parallel lines. And what I want is the distance, the horizontal distance between these two. So one way of doing this is to take a point and drop it here and take a perpendicular line and drop it through E. And now I need to find this intersect. So if you're lost, just watch me and then I'll show you what I'm doing. Intersect, very nice command. It's under the point, 1, 2, 3, 4, intersect. What do I want to do? I want to intersect this and this. I'll repeat this again, so just watch me if you're lost.
Jūs čia projekciją radot, ar ne?
Yeah, projekcija, teisingai. So I will hide this. Now you don't want to delete anything in GeoGebra. Watch what happens. If I delete this line, I delete the intersection. Jeigu aš išnaikinu tėvus, aš išnaikinu vaikus ir anūkus ir proanūkus. Tai tik pakavokit. Just hide anything that you don't want. So I repeat, perpendicular line, perpendicular through E, and then I find this intersection. And now I'm going to hide it. And there's two ways of hiding it. You can right click and do show object, or you could go to the algebra window and just touch this button and it's hide on, off, on, off. Very, very nice. Very nice. Okay, so I'm going to hide this. And then I will make this segment in here, segment, right in here. And I'm going to change this name. And there's many ways of changing it. Right click, rename. And I could say lateral loft. Or, and I'll repeat all this, I could rename it with a right click in the algebra window. Lateral loft. Okay, so that's one way of doing it. Another way of doing it is what is the kitas būdas šitą padaryti yra tik paimti x taško A ir x taško F ir subtract du dalykus. Atimti. So I show you, I'll show you this. Lat loft version 2 is x of point A minus x of point F. And what happens is, of course, the answer is the same. You could see that this number is the same whether I yra tas pats skaičius, nepaisant ar aš žiūriu į liniją arba atimti x coordinates. Okay, and then finally I need the angle. I need the angle. And the angle is really easy in GeoGebra. Labai labai paprasta. It's over here under angle, and it says select 3 points or 2 lines. Jūs turit tik su pelyte paliesti tris taškus. Now, the order does matter, and I will show you. You don't have to memorize anything. So I will do this. I will touch the angle, and I will say F, B, A, and now you could see the angle in here. Let me delete this. If you go the other direction, į kitą kryptį, A, B, F, you get the other angle. So you could just take a guess. Jūs galite tik spėlioti, ar į vieną kryptį, ar į kitą kryptį, nesvarbu. So I will go F, B, A. And that is the angle. Now watch what happens. So now I have the lateral loft that the giraffe force is feeling. Tiktai skersinis, ne vertikalinis. Ir aš turiu tą trikampį, that angle. So now I have the two things that I need. And now watch. In my input bar, I will say moment Mueller-Breslau equals giraffe, no, is equal to, yeah, giraffe times that distance, lateral loft, divided by alpha. Alpha is Greek, čia graikiška raidė. So look over here on the far right, iš dešininės pusės yra graikiškos raidės čia. Ir galit graikiškai parašyti. Okay, so now, let me repeat one more time. I have the angle. I have the lateral loft. Aš turiu šitą kampą ir aš turiu šitą projected distance, tą skersinę atstumą. And what I want to do is this. I want this. Because this is not algebraic statics. This is Mueller-Breslau. I want to solve this equation. This force is the giraffe on ice form. Šitas yra tas girafos kojos. Šitas yra tas skersinis atstumas. Ir šitas yra tas trikampis. This is the giraffe on ice force, which you don't know. I'm not telling you how to get that today. You will find out on Thursday. This is the distance, and this is the angle. And I'm solving for the moment. So watch me do it one more time, and you could follow along here. Moment Mueller-Breslau is force, the giraffe force.
Screen share, Edmond, please.
Yep. Ačiū. Turi daug kantrybės su manim. Labai gerai, ačiū. Labai dėkuoju. Okay, here we go. Moment MB. Moment MB. Input. Moment MB equals giraffe times the lateral loft, paskersinis atstumas, divided by padalint iš to trikampio, the angle. And that angle is Greek here, it's alpha. So go find this Greek letter right here, alpha, boom. And notice the answer. The algebraic answer was 660. It doesn't matter what your numbers are. And moment MD is 611. You may have different numbers. If we make the height 10, something different, obviously the numbers change. Now, why are they different? They're close. Jie beveik tas pats, bet netiksliai tas pats. Ir čia yra modernus Mueller-Breslau metodas. Now watch what happens, and hopefully somebody will go, My students never do that. So if you do that for me, I'll be very happy. Okay? Not yet, don't do it yet. So we're watching the moment Mueller-Breslau versus moment algebra. And this, now I'm going to move point F and watch what happens. 630, 640, 650. And as this gets very, very small, this answer approaches the algebraic theoretical exact answer. Right? So this has never been done before. As far as I know, nobody has ever done this before. So aš bandau nebūti egoistas, bet čia aš tik tai pandemikos metu šitą išsprendžiau viską, kad čia nėra algebra, čia mes visai algebrai podstatyk nenaudojam. Mes naudojam geometrinius būdus ir mes galim nupiešti šitą, bet bėda yra, kad kai tas trikampis labai mažas yra, tai mes jau nebegalim įskaityti ant brėžinio. So what I said in Lithuanian was that this method is beautiful on a computer when you are drawing the geometry because you can see the very, very small angles. But if you're a student who doesn't know anything, which is my students, by the way, okay? And you draw this and you say, okay, let's make it 45 degrees, you know? I'm way off. What if I made it 22.5 degrees?
Screen share.
Yes. Yeah, you just keep saying that, okay? We have, oops, the wrong one. So watch. So what if it's 45 degrees? 45 degrees. Everybody can draw a 45-degree line on their notebook, right? Moment algebra is 660, moment Mueller-Breslau 592. Not so good. But what if it's 22.5 degrees? Everybody can draw 22.5 degrees. Now moment algebra is 660, moment Mueller-Breslau is 643. I think that's good enough. For engineering, that's good enough. Good enough. Okay, let's go back. We only have 30 minutes left. So because I have to have breakfast at 8:30. So, okay, so on this picture here, on page 5, I show you this idea that for a large
screen share.
Yes. For a large displacement, 33 degrees, the answer is so. For smaller angles, the problem becomes much more accurate. Okay, so now here's your homework, and I will stop talking and you will start learning. As soon as I stop talking, my students start learning. Tai yra pamoka mums visiems. Kai mes profesoriai baigiam kalbėti, tada mokslas prasideda. Okay, so here is your homework. What I want you to do is draw a frame. You could draw a frame. You've got it nupiešti bet kokį rėmą. And use my cheating guide here. This is cheating of what the giraffe on ice force is. So let me explain this picture for you. In the first picture, the columns are very strong. Kolonas yra labai stiprus, o sija yra labai silpna. What is the giraffe on ice? The giraffe on ice is essentially 0. Why is it 0, ladies and gentlemen? It is 0 because Daria prašo gauti tą dokumentą vėl, bet Daria ėmėsi. Why is the giraffe on ice 0 for a very stiff column and a very flexible beam. Kodėl žirafa yra nulis dėl šitos ekstremos? Kadangi ta pamokėlė, kur aš jums daviau iš karto, that first exercise, it doesn't work, it's not a frame if you have a very, very weak connection here. There's no moment transferred. There's no moments transferred. It's not a frame. So this is an extreme, cheira extrema. Okay. Okay. The second one. Suppose that your column is 4 times stiffer than your beam. 4 times. And the load is only on the beam. What is the giraffe on ice? Either 0,023 ir tas atstumas. It's 0.023 times the distributed load times the span of the beam. And now we go further and further. Suppose, secontis modulus, suppose it is 1/2, so that the beam is 1/2 as stiff as the column. Tas standumas yra 2 kart didesnis kolonė. What is the giraffe on ice force? Koks yra žirafos apkrova? 0,038. Ir taip toliau, and so on and so on. And finally, we have another example where it's a 1-to-1 ratio, 1-to-1. And then 2-to-1. And finally, the extreme, where the beam pasija yra labai standi ir kolonas yra labai lankstus. This is the limit. Čia yra riba. O 0,083. 0.083 is the limit. Okay, now this is, I will explain how I got those next time, but I want you to do the Mueller-Breslau method on the beam. I want you to do the Mueller-Breslau method on the beam. Okay, so now I hope we can do this. I don't know if we're going to have time to do this. This is going a little slower than I thought it would be. The Mueller-Breslau construction for the beam is as follows. Let me skip that for a second. Let me skip this for a second and get to this next part here. Okay, so what I want you to do for homework, namų darbai, I want you to do this. I want you to draw a frame and you choose the height and you choose the width. But don't do what I'm doing, my example. Don't do 1-to-1. Do something different. But for practice, you should do my example. Now, what I want you to do is understand this, and this might be a little hard for the people who have no structural knowledge. Čia gali būti sunkoka tiems, kurie neturi statybos, bet kitiems bus paprasta, ne paprasta, bet bus suprantama. If I know what the moment at the top of the column is, then I know what the moment at the end of the beam is. I will repeat this lietuviškai. Jeigu aš žinau, koks yra momentas kolonos pačiam viršūnėje, taigi aš automatiškai žinau, koks yra momentas sijos gale. They have to match. The moment at the top of the column must match the moment at the end of the beam. But notice, pastebėkit, that this moment diagram is the classic moment diagram for a simply supported beam. Šita diagrama yra ta, kur mes išmokom pradžios mokykloje. Yra parabolė ir ji nėra sudėtinga. This is not a complicated diagram. This is not a complicated diagram, but it does not start at 0. It starts at the point of M top. That's why we did all this exercise here. Lietuviškai. Sija mes vaizduosim, kad yra statiškai apskaičiuojama, bet neprasideda su nuliu. It does not start at 0. Okay, so let's see. So what I want you to do is this. I want you to draw, maybe I'll do it this way. Let me do it this way. Okay, let me do this. Okay, so what ką aš norėsiu, kad jūs padarytumėte? What I want you to do for homework is draw a frame, and it doesn't matter what size it is. You know the height, and you know the width. You decide, jūs nutarkite. And these forces here are known today. Jūs žinot, kas šitas yra, because you are using my template. This is the giraffe. Now, you will get this force. Oops. You will get this force using my model, 0.023 or 0.038 or whatever it is, blah, blah, blah. And then you will draw this bending moment diagram as a straight line like this. And now here's the key idea. This is the same. This is the same bending moment diagram here. And this bending moment diagram is the simply supported bending moment diagram. It's the statically determinate one, but it starts here and ends here. So I call this M restraint, and I didn't invent this. This is standard. Čia ne mano kūryba, čia yra M restraint arba sulaikoma, kas yra sulaikoma, and this is M free from here to here. That is M free. M free, or M statically determinate. Okay, so now let's start a new. Let me start a new GeoGebra file just to show you one more time how we're going to do this. So I will share my screen here and start a brand new file, and this is your homework. And so let's try this. So let's say A is a 0, 0. One more time. And I'll just type in height here. I'll type in height is 7 meters maybe. And there's no meters in GeoGebra. We'll just say it's 7. And I'm just making up some numbers. Width is 10 meters, maybe. There's no meters, it's just a number. So watch me do this and see if you could follow. B is A plus 0 and height. C is B plus width, and D is A plus width. We did this already, so far so good. And then I could draw the frame. So far so good. And now what is this ratio? Let's say ratio is width over, wait, let me make sure. Hang on. Yeah, width over height. So width over height. Okay, so now the default is symbolic. We could change the number to be a real number. Default yra kad yra simbolinis fraction, bet mes galim labai paprastai pakeisti tą. So it's 10/7. So I right click, and I hit object properties. And over here under algebra, I unclick symbolic. And it's 1.43, the ratio of the, I think I did that right here. The width to the height is 1.43. So 1.43, so the width to the height. So now what I'm looking for is EI over L of the beam and EI over L of the column. So sorry. I need to go here. So my ratio of beam width to beam height is 1.4, bevek pusantro. But that's not the way I set up this table. Notice I said EI over L of the beam and EI over L of the column. So if I have a stiffness ratio, so let me just say EI is 1. So let me stop share here, stop share. Let me say EI is, it doesn't matter what EI is. Let's say EI is 1000. It doesn't matter what it is, okay? So now I can say EI over L beam is EI divided by width. Oops. Oh, sorry. EIL, let's say EIL beam. EIL beam is EI divided by the width. And EIL column is EI divided by the height. The stiffness ratio is EIL beam over EIL column. And that is 7/10. 0,7. So the reason why I did this was I want you to see that it's not that you could change the E and the I of the beam, or you could change the E and the I of the column, or you could change the width of the beam frame or the height of the column frame. Lietuviškai. Jūs galit medžiagą pakeisti, arba inercija, moment of inertia, arba jeigu yra lygiai ta pati medžiaga ir lygiai tas pats skerspjūvis, tas lankstumo ratio yra vis tiek, jis yra, reikia padalinti iš atstumo. You have to divide by the lengths. And let me share the screen. one more time here. And this will make sense if you study this a little bit. So I wrote it here as EI over L of the beam. Sijos standumas padalintas iš kolonos standumo. And for us, in this example, it was 0.7. That was somewhere, where was it? 7? Yeah, 7/10. So I need to find, it's a little bit, it's in between this. So this number is 1/2, čia yra 0,5 ir šitas numeris yra 1. So I have to, because I made it 7/10, it's not on my chart here. It's in between. It's either tarp šito ir šito. So you could just take 0.045 maybe. So let's just say the giraffe is 0.045. So now I need a load here. I won't draw the loads and all this stuff, but suppose there's a load over here. Oops. Just pretend that there's a load up here on the beam.
We need to go back to GeoGebra.
Pretend there's a load on the beam, and let's just say that the load is 100 kilonewtons per meter, something like that. So Q is 100. And this is kilonewtons per meter. Q is kilonewtons per meter. Q is kilonewtons per meter. But I don't have meters in GeoGebra or anything, and I don't have kilonewtons. So now the giraffe is roughly maždaug 0.045 times Q times the width. Let's find out what our giraffe is. 45 kilonewtons. So that's 45 kilonewtons. So that means that the giraffe for my problem is 45 kilonewtons. That means that the moment going up to here is 45 times the height. And that would be, and you could do this algebraically, or you could do this with Mueller-Breslau. So M top algebra is giraffe times height. Okay. And then that means that this point at the start of the bending moment diagram and at the end of the bending moment diagram, that it must be 315 for me. And what you want to do for homework is this. Let me just show you. And you could do this as best as you can. What I really want you to do is find the bending moment in the middle of the beam. In the middle of the beam. Now there's two ways of doing this. And we don't have time for me to do the Mueller-Breslau, so let me just show you the algebra. Let me show you the algebra, and then maybe next time we'll do the Mueller-Breslau. If anybody comes back. Jeigu kažkas grįž ketvirtadienį, mes galim padaryti Mueller-Breslau. Bet dabar nėra laiko. Okay, so this čia yra Mueller-Breslau. I will show you this next week, on Thursday. But for now, let's pretend that it's algebra. So algebra is very, very simple here. It's Q times W squared over 8. It's Q times W squared over 8. Now, the trick is to recognize, čia reikia atsimint, kad mes nepradedam su nuliu, mes vaizduojam, kad čia yra statiškai apskaičiuojama sija. We're pretending that it is determinate, and we are starting at the M top of the column, and we are dropping down WL squared over 8, or Q times W squared over 8, sorry. And this is the picture. This is the picture. So this number here is, let me go back to this. This number here is Q times W squared over 8 by algebra. But it starts at this point here. It doesn't start here. And then you could draw the bending moment diagram like this. And that's the end of your homework. So for homework, pick an H, pick a W, dėl namų darbo. Išrinkit H, išrinkit plotmę, išspręskit girafą, find the giraffe, find the M on the top. Once you have the M on the top, that's the same as the M at the ends of the beam. Čia yra tas pats. Ir tada nusileiskit šitiek nuo tos vidinio taško. From that middle point, drop this down, and then you should have this picture, the one that we started with. The one that we started with, right? Your first sketch, this one. And that's what it looks like. Now, we ran out of time because I did not show you how to do this on Mueller-Breslau on the beam. Mums pritrūko laiko, bet aš jums parodysiu ketvirtadienį, jeigu grįšiu. Okay, so now, oh, that was crazy. Maybe a couple of comments, a couple of questions.